object-oriented programming, inheritance. So, inheritance is one of the main pillars of object-oriented programming. And the idea is that we have a more general classes and then subclasses that are more detailed. And those subclasses inherit the features from the superclass, those more general classes. For example, text student inherits a student's and humans functionality. And here the table would have all the features in furniture. So idea of inheritance that we have classes that are organized as a hierarchy, and subclass inherits the information and functionalities of superclass. And we can have abstract superclasses which are only abstract. You cannot create objects out of them, but we will cover this topic later, not on this video. We have these super and subclasses. So how many attributes does the poodle have in this case? So we have a poodle class that is inherit from dog, and that's inherit from mammal class. So dog is a poodle's superclass, but mammal's subclass. And this means that the poodle has 4 attributes: weight, number of legs, these come from mammal class, rapidness comes from dog class, and the number of diamonds in necklace, which comes from the actual poodle class. So 3 attributes come through inheritance and 1 of its own. And inheritance in Java, so basically we can have a class, let's say we have a hedgehog class, that inherits features from another class, let's say animal class, using the following syntax. We create a class as usual, public class hedgehog extends animal. So we are creating a hedgehog that is extending the class animal. So we should have the animal class as a superclass, and then we are creating this hedgehog class, which is taking the benefits from the animal class. And superclass functionalities can be overwritten by making a method with the same name to the subclass. And searching for an appropriate method starts from the subclass. If none is found, program moves up in the hierarchy tree. So then we have this calling constructor. So in Java, subclass calls the default constructor of superclass automatically. Default constructor is constructor without parameters, and this might create an issue. And if and when we usually want to call another constructor, we can use the keyword super. So let's say we have this hedgehog class which is calling animal class constructor just by calling super and giving a parameter name and integer value of for the tree. We can also call another constructor in a superclass only with name parameter if there is such a constructor. Of course, we only call one constructor at a time, but in different classes we can call different constructors, or we can have a constructor that takes 3 parameters, then we can call that too. And calling the correct constructor is of course important, and the response for that is programmers to call the correct constructor. Visibility definition. We have been talking about, we have these private and public things. So private, it's the most limiting. Only the class itself can use those methods or attributes that have been defined as private. And what should be private? Instance variables So all these instance or member variables, for example, human has a feature or the attribute called name, that's usually private, or age. Helper functions, if we have a function that is only working inside the class and it should not be given to any other object to use or classes to inherit, then define it as a private. Then we have the package visibility definition. This is new one. Everything is visible within the package but not outside. So in Java you have the package visibility level. So basically your code is always on some package. You can have several packages in your program. A package is basically a folder. So code in one folder can see other code in that folder if the visibility level is package. And this is the default visibility in Java. So if you are giving no private or public or any other keyword, then it's package. Package is the visibility level. But there are more. There is this protected, and this is very useful when you are using inheritance. It lets subclass to use members of superclass. For example, if we have a hedgehog class that needs to use features of animal class, the features need to be set to protected or public. But if we have just attributes that would need to be usually private, but we want the subclass to have access them, then we could use the keyword protected and set the visibility level to protected. And then finally we have the public, which is defining public interface. Everyone can use it. It's completely public. So you have to be careful when leaving things to public. Usually you don't want to. It's a public interface, so you have a method that is public. It's a promise that you have this kind of a service in this class and you provide it to other classes to use. And things related to interface should stay unchanged. So for example, if you are thinking about you are building a Twitter client to your mobile phone, it's using Twitter API, and Twitter decides that they are chasing the API every month, then you would need to modify your own Android application every month, and you don't want to do that. So when you are releasing your class and you're defining that there is this kind of a public API, then you should not change it. You can improve it internally, or you can publish a new version of the API with a bit different name, for example, but the already released API, the public interface, should stay the same, unchanged. And the interface should be minimal but perfect. So as less as possible, but make it as visible and as big so that it's it's useful, so you can actually use it. And definitely do not put something for just in case. It's not good. If something is missing, the user of the class has no chance of fixing it. It's the responsible of the class developer to build the class correctly. Instructions. So instance variables, attributes should be private and hidden. Hiding information is one of the main points in object-oriented programming, so that no one can mess up your variables in your class definition. There may be need to transfer or change instance variables, and you cannot do that if they are set public. So if you want to change the name for example, or type, but you cannot do that if you have already published them as a public interface. So if variable is public, object cannot know when the value is read or changed. So you cannot have any control in that. So that's why you want to encapsulate it. And overriding functionalities, so subclass have two options when inheriting. It can accept the implementation of a method from superclass. So if an animal can walk, then hedgehog can define that, okay, I can walk too, that's fine with me. Or they can create their own implementation for the method. So if hedgehog decides that I cannot walk, when I'm walking, I'm actually running, then the hedgehog should override the walking method to call, for example, running method. And the overriding method offers the same services as the original method, so you basically cannot and you should not override the hedgehog walk method so that the hedgehog would start to fly. That's not the same service as the original animal walking method. Subclass just changes its implementation, not its interface, the meaning what it's doing. And let's have an example how to use all these inheritance things in Java. So let's continue with our star-based code. And last week we had this parameter things. We can now remove those. We don't need anything like this. Now we don't have anything here. Let's just start by developing a new rocket. So let's add few rockets so we can have Saturn 5 here, and then we could have a few more. Starship. And let's have also the Chinese future Long March 9 if it's some day in future coming. Now we have 3 rockets. So we are not using this rocket which is in future be abstract class, but let's have it now so that it takes parameters. Let's utilize that name first of all, that haven't been used. So it's taking name, it's taking max size of cargo and max size of astronauts, and then we can have these like that and this like that, and then we have still this string, this name coming. That's missing an int. Okay, so yes, now we have a constructor that takes 3 parameters: a name, max size of cargo, and max number of astronauts. And we have this could actually be also final, this name, so you cannot change it once it's initialized, and it's initialized here. And this parameter, first parameter's name is name, so it's the same name that is this member variable, this attribute. So to access this member variable we need to have this keyword, because this makes absolutely no sense. These are now these 3 highlighted are same variable, but now we access this member variable. Or we could of course have the name like this. This would be definitely also okay. There are plenty of ways how to handle these kind of things in Java. but you see this kind of code quite often. So this is what we will have. So let's copy paste this one and let's start this Saturn 5. I'll just copy paste a few things here. So we are extending the rocket class, and in the constructor of Saturn 5, which is of course public, we take no parameters, but we are calling the rocket constructor with this super keyword. Like this. And of course now we are not defining the types. So now we should give these three parameters. So the name is Saturn 5. Max size of cargo is something like 130,000 tons or kilos. Max number of astronauts. So Saturn 5 could have 3 astronauts up until the moon. So this is the specs for the Saturn 5. So let's copy paste this code and move to the Starship. And Starship can have 150 metric tons of cargo and 100 people. It's a big ship. And then Long March 9, which not that one, but let's copy paste this one. Long March 9, that is also a big ship, spaceship, and it can have, let's say, 140 metric tons, and let's give it this Chinese name like this, and it can handle 4 astronauts, whereas Saturn 5 could handle only 3. And the Starship can handle 100, which is much more. Then let's modify this, as we are now using this name, so we are not just telling this rocket has the following astronauts, but let's have it like this. So name plus has the following astronauts. So now it's telling the rocket name. And then is there something other? Here we are calling rocket. So let's change this so it would be name plus has been test launched. And similarly here. And now our rocket, we had these astronauts as a string. Let's modify, so these are real astronauts, not just strings. Astronaut. So then we need to modify also this for loop. Now we are not looping strings, we are looping astronauts, and then we are just not printing S, but S get name, so we are getting the astronaut name here. And then this add astronaut, we are not getting strings, but astronaut, and their return type is astronaut, and we cannot return string as our return type is astronaut, so we are providing null if there is no astronauts. And it should be okay. Let's see if this works. So let's first build a new Starship. So we can have Starship as a new Starship. We do not need to give any parameter. And yes, I'm not able to write it correctly. And then this Starship, what we can do with it, we can why we cannot, there should be set, oh no, we have add astronaut, of course, yes, add astronaut. So let's add new astronaut called Lee, which has age of 42, and let's copy paste a few more astronauts there. So Anna, Ernest, and maybe Daniela. Similarly, we could set some car code there. Or do we have add cargo? Yes, add cargo. Satellite A and B. And we had the function print information. Let's see what happens if this code is still working. It seems so. So the Starship has the following astronauts. There are 4 astronauts and the following cargo. And let's build another rocket. Now we can make Long March 9. Rocket called LM. It's new Long March 9. Yeah. And once again we can just copy paste this here, add astronauts. Okay, these ages are all the same. Let's modify, because I don't want to have the same age astronauts there, or Tigernauts. Let's try to add 5, as we have defined that this Long March 9 can have only 4 astronauts, but let's put 5 astronauts there. So Lee, Jen, Ahlam, then a bit not that easy word, and Locke. Once again, I don't want to have them age to be the same. And we could add some cargo there. So let's put a moon rover there. This Long March 9 is heading to moon. And let's see what happens. And we have failed. Yes, there is a mistake. We should have a correct constructor here. Now it is correct. And yeah, so this is working. Here is the Starship and here is the Long March 9, and it has the following 4 astronauts. So this Locke was unhappy and it did not fit in the rocket. But now we just have 3 quite similar classes, which is not what we want. Let's add some functionality here. So Starship should have something else. It can land. It's the only rocket here that can land. So let's add the functionality. Just so has landed successfully. Like that. Now it's the rocket that can land. There is no such functionality in the rocket class, but in the Starship class there is this functionality. So now Starship has function to land, but this Long March 9 does not have function to land. This does not work as there is no method for landing. But let's try it. So now Starship could land. Starship has landed successfully. But how can it land when it has not launched? So let's launch it first. Launch. Now it has launched and then it has landed successfully. So we could set there should be some kind of a variable telling that if it's on ground or if it's not, and if it's not on the ground then it can land, but now we don't have that kind of a functionality, but it doesn't matter. So now we are using inheritance here. Our Saturn V and Starship and Long March 9s, they have been inherit from this rocket class. They are extending the rocket class, and then this rocket class does have these astronauts. So there is aggregation or composition. We haven't decided what should be, but in this case it is basically composition. We have these astronauts here. So this is how we use these tools that we have learned, composition and inheritance, has a and is a relationship. So Starship is a rocket. So there is a abstraction, and rocket has astronauts. So there has a abstraction. To use astronauts, we only need to know that there exists this astronaut class, and then we can use its public interface. So in this sense, now we would like to have, of course, these rocket variables. So these should be protected. So now these, so let's see if we have these astronauts and this is private. So now we want to give a Saturn V, let's have a Saturn V public method to DV interview. And what we do here, we just want to go through the astronauts and say all the astronauts say hello. So astronaut A, get name, system out, print. Something like this. But this is not okay because this astronaut cannot be found. So it's location class Saturn V, there is no astronauts. But here in the rocket class there is, but this is private. It should be private. Now it's private. And what is this saying? So there is no astronaut. But now if we modify this so it would be protected. So now the subclasses have access to these astronauts. Now it's fine. We have access to these astronauts, so we can use it. So now we can build one more. So let's build a Saturn 5. And as we add astronaut, let's just copy paste here. And now this as we can do TV interview. Let's try it out. So TV interview is going well. So let's just add here print so it's TV interview starting, and those astronauts that are inside the rocket are saying hello. And now the Saturn V is only rocket that can have this interview functionality. We cannot interview other astronauts in other rockets, so Starship doesn't have that kind of a functionality, and Long March 9 does not have any functionality right now, but of course we could give some functionality there. But I think this is what I wanted to describe. This is how inheritance happens in Java and how we can extend our classes and get the benefits out from that. So, as a conclusion, inheritance is a cornerstone of object-oriented programming. It gives programmers flexibility to build classes that can utilize other classes as basis for their implementation.